This is topic 3.4.1, chain rule for partial derivative. So let's just look at some theorem. Okay, suppose that z is a function of two variables, x and y, and x is a function of t, y is a function of t. Then the chain rule for dz dt will be this. The second theorem says that if you have a z and z is a function of two variables, x and y, and x is a function of two variables s and t, and y is a function of two variables s and t, then the chain rule for del z del s will be this one, and del z del t will be this. But do not worry about the formula. You don't have to memorize the formula, where you just need something called tree diagram to help you to solve the questions that involve with chain rule. Let's just look at example 1. So example 1, they ask us to find dz dt when t equals to 0. So you need a tree diagram in order to find the formula of dz dt. Okay, so we begin the tree diagram by analyzing the equation that we have in the example 1. So first of all, you have z equal to 4x squared y plus 3xy cubed. So it means that you're going to begin your tree diagram with the node z. And because inside the equation z, you have two variables, so that's why you're going to draw two branches. So these branches will end with x and end with y. And since you are having two variables, so you're going to have partial derivative. So this is moving from z to x, you're going to have del z del x. And this one is moving from z to y, so you're going to have del z del y. And please take note that del z del x is not equal to dz dx. Okay, we are using the del z del x here because you have two variables. Okay, dz dx is when your equation only have one variable. Okay, so let's just continue to draw the tree diagram. So what happened to the x? Okay, so in the equation x, you only have one variable, that is t. So you're going to draw one branch. So that one branch ends with the node t. Okay, you are moving from x to t, so you're going to have dx dt. And same thing happened for the y. You only have one variable, that is t. So you could draw one branch. So that is end with the t, and since you are moving from y to t, so you have dy dt. And please take note that dx dt is not equal to del x del t. We are using dx dt here because you only have one variable inside the equation x. Okay, let's just see what happened to the formula. You have dz dt. So let's just let's just figure out what is the formula for dz dt. Okay, so you have to begin the formula by analyze the tree diagram. Okay, what you have to do is you go to find the end node that is t. Okay, so you have the end node that is t. This is the first branch. So this first branch, okay, is getting from the node z. Okay, the node z that is moving from z to x and x to t, and along the path. Okay, the thing that you can see here is you see the partial derivative del z del x, and you see the derivative dx dt. So what you have to do is you multiply both of them. Okay, you multiply the del z del x with dx dt. So we have here. Okay, and do not stop your formula at here because you have another branch that is also end with t. So this is another branch that end with the node t. So this node t that is getting from the node z, okay, the node z moving from the node z to y, and from y to t. Okay, along the path, the thing that you can see here is you see del z del y, and you see dy dt. So what you have to do is you have to multiply both of them. Okay, so you multiply the del z del y with dy dt. So that is the formula for dz dt. Now we have known the formula of dz dt. Okay, so now we need to solve this example. So if you look at the chain rule, okay, the formula that we get from the chain rule, so the information that we need, the next is the del z del x and del z del y, and we need the dx dt and we need the dy dt. So let's just find the del z del x and del z del y first. Okay, so where to obtain the information of del z del x and del z del y? That is from the equation z. So what you have to do is you have to find the partial derivative, okay, from this equation z. So let's just find del z del x. Okay, so this means that you treat the y as constant, focus on x. So you differentiate on x, so you have x squared here. So differentiate x squared, so you have 2x. So 2x multiplied with constant 4y, so you have 8xy. So focus on x here, so you differentiate x, you have 1. So 1 multiplied with the constant 3y cubed, so you have 3y cubed. Okay, the next thing is you need to find del z del y. So del z del y is you focus on y, treat x as constant. Focus on y, so you differentiate y, you got 1. So 1 multiplied with 4x squared, so you have 4x squared. So focus on y, so you differentiate y cubed, so you have 3y squared. 3y squared multiplied with the constant 3x, it gives you 9xy squared. Then we need to find dx dt. So you can get the dx dt from the equation x. So this is the equation x. So this one you need to use the chain rule to find dx dt. So we have 5 cos 5t. Okay, and same thing happened for the dy dt here. So you can get from the equation y. So your dy dt, that is minus psi t. Okay, now we need to do the substitution. So what is your del z del x? So your del z del x is 8xy plus 3y cubed. Then do the substitution at here. And then the next is the dx dt. So what is your dx dt? So your dx dt is 5 cos 5t. So do the substitution here. Okay, and then you have del z del y. So what is your del z del y? So del z del y is 4x squared plus 9xy squared. So do the substitution here. And last we have dy dt. So what is your dy dt? Your dy dt is minus sine t. So do the substitution here. Okay, now we temporarily stop our dz dt at here because we need to look at the further information that we have, that is when t equal to 0. So they want you to find dz dt when t equal to 0. So what happened is actually you can substitute the t at here and t at here. But what happened to the x and y? So you need to figure out what is the value of x and y before you do the substitution. So where to obtain the information of the x and y? So that is you can obtain from here. So when your t is actually equal to 0, so your x is sine 5t. Okay, so you can substitute the t as 0 into here, then you have your x is actually equal to 0. And same thing happened for your y is actually equal to cos t. So since the t is actually 0, you can substitute here, you have y equal to 1. So it means that when your t equal to 0, your x is actually 0, your y is actually 1. So now you have the information about the t, x, and y. You can do the substitution into the dz dt. So substitute the x as 0 here, y as 1, y as 1, t as 0, x as 0, x as 0, y as 1, and t as 0. And you have the next line. And simplify it. Okay, and simplify again, you have the answer, that is dz dt equal to 15. In example 2, you need to find del z del r, del z del t when t equal to 0, r equal to 2. Okay, first of all, let's just construct the tree diagram. Okay, let's just analyze what we have in the equation z. So in the equation z, we have the variable x and y. So you should begin your tree diagram with the node z. And because inside the equation z, you have the x and y, so you will have two branches. So one is n with the x, another one is n with the y. So because you have two variables, it means that you're going to use partial derivative. So you have del z, del x, and this one is give you del z, del y. Okay, so let's just look at the equation x. So inside the equation x, you have the variable r and t. So it means that you're going to have two branches. Okay, so you're going to have two branches. One is n with the r, and then one is n with the t. So now because you have two variables, so you're going to use the partial derivative. Okay, so moving from x to r will give you del x del r, and moving from x to t will give you del x del t. And please take note here that the del x del r is not equal to dx dr. Okay, we are using the del x del r because you are having two variables here. Okay, dx dr is when your equation has only one variable. So then let's just look at the y. So the y, we have the r and t so means that you're going to have two branches. So n with r and n with the t. So moving from y to r will give you del y del r, and moving from y to t will give you del y del t. Okay, let's just look at how to write the formula of del z del r. Okay, in order to write the formula for del z del r, you need to check on the node, okay, that end with the node r. Okay, so this is the first node that you can see here. Okay, this is actually at this branch. Okay, this is actually begin at the node z, and from the node z move to the node x, and from node x move to node r. Okay, along the path, the thing that you can see here is del z del x and del x del r. So just multiply them. So you have del z del z del x multiply with del x del r. Okay, and then we have another branch. So you have to plus another branch. So another branch that ends with the r, that is this one. So this is actually begin with the z, and from the z is moved to y, and from y it moved to r. Okay, so along the path that the thing that you can see here is del z del y and del y del r. So multiply both of them means that you're going to multiply del z del y with del y del r. So this is the formula for the del z del r. So once we have figured out what is the formula for del z del r, we need to figure out what is the formula for del z del t. The formula for del z del t means that you need to check the branch that ends with the node t because we are looking for del t. So the first branch that you can see here, this is the one, okay, that is actually begin from the z to x and x to t. So along the path, the thing that you can see here is del z del x and del x del t. So multiply both of them means that you have del z del x multiply with del x del t. Okay, plus with another branch. So another branch that ends with the t, the node t, that is this one. So this is actually begin with the z and it move to y, and from y to t. So along the path, you can see del z del y del t. So multiply both of them. This means that you will multiply del z del y with del y del t. So this is the formula for the del z del t. Now we have known the formula for the del z del r and del z del t. Okay, let's just go to the solving part. Okay, so let's just begin with del z del r first. Okay, so this is the formula for the del z del r. And before we do the substitutions, you need to figure out what is the del z del x, and then the rest of the first order partial derivative. Okay, let's just begin with equation z. Okay, so this is the equation z. Okay, let's just begin to find the first order partial derivative of the z. Okay, for the equation z. So for the del z del x, okay, so we're going to focus on the x and treat y as constant. So ln, you differentiate ln, you have 1 over the bracket Okay, and then by the chain rule, so you have to differentiate whatever inside the bracket. Okay, so focus on x, so you differentiate 2x, it will give you 2, and this constant you actually have 0. So that's why you have del z del x as 2 over 2x plus 3y. Okay, same concept apply to del z del y. So we're going to differentiate ln. We have 1 over the bracket, and now we're going to focus on the y. So x is actually constant. You differentiate constant, you have 0. You differentiate 3y, you give you 3. So then you have your del z del y. Then we go for the next equation, that is equation x. For this equation x, let's just find out what is the first order of partial derivative. Okay, so let's just go for the del x del r. Okay, that means that you will focus on r. Okay, and the t actually is constant. So you differentiate r, so you have 1 multiplied with the constant, that is the exponent to the t, so this is the exponent to the t. And for the del x del t, that is focused on the t, and r is constant. So differentiate et, so you have et, multiply with constant r, so you have ret. Okay, then we go for the y. So for the equation of y, let's just find out what is the first order of partial derivative. Okay, so let's just go for del y del r. So for del y del r, you focus on r. So r squared, you differentiate, you have 2r. Then multiply with the constant, that is e to the power of negative 3t. Okay, then for the del y del t, okay, so that is you are focused on the t. Okay, so we differentiate the exponent to the power of negative 3t, so you have negative 3e negative 3t multiplied with the constant r squared, so they basically give you negative 3r squared e to the power of negative 3t. So we have done with all the first order of partial derivative. Let's just do the substitution. Let's just go to the first one, that is del z del x. So what is our del z del x? That is this one. So we do substitution. So we have here, and then we go for del x del r. So where is our del x del r? So this is our del x del r. Just substitute inside here. And then we go to the del z del y. So what is our del z del y? This is our del z del y. Okay, and then you have del y del r, and this is the one. This is the one, del y del r. So just do the substitution. So we have this one. So we temporarily leave our del z del r in this way because we need to look at the further information that we have. The further information that we have is t equal to 0, r equal to 2. Okay, so you can substitute the t equal to 0 and r equal to 2 into here, but you need to figure out what is our value of x and y. Okay, how to figure out the value of x and y? That is actually you can obtain from these equations. Okay, so you know that your x is actually equal to ret. Okay, so what happens when your r is actually 2 and t is actually 0? You just do the substitution, you have the x is actually equal to 2. And same thing happen for the y. So you know your equation of y, and you do the substitution. So you can substitute the r as 2 and the t here as 0. Then you have y is actually 4. Now you know that when your t equal to 0, r equal to 2, you will have your x is 2, y is 4. And let's just do the substitution. So you can substitute. Okay, so the x here is 2, the y is 4, the t here is 0, x is 2, y is 4, r is 2, t is 0. Okay, then you have the del z del r here. Okay, then we simplify it. And simplify it, so we have del z del r is equal to 7 over 8. We have settled with del z del r. Then let's just look at del z del t. We know that the formula for del z del t is this one. Okay, and then we need to do the substitution. So let's just do the substitution. What is our del z del r? So our del z del r is this one. And what is our del x del t? So this is our del x del t. And then plus with del z del y. Where is our del z del y? Del z del y is this one. Okay, and then multiply with del y del t. So this is our del y del t. Okay, now you need to do the substitution. So we know that t equal to 0, r equal to 2, our x is actually 2, y is actually 4. Okay, the thing that we obtained just now. We just do the substitution. So we have x equal to 2, y equal to 4, r equal to 2, t equal to 0, and so on. Then we have the next line. And simplify it, and you will have the answer of the del z del t that is equal to negative 2. Let's just look at the example 3. In this example 3, they ask us to find del u del r. Okay, so to find del u del r, you need to construct the tree diagram. So let's just analyze what we have in the equation. So in the equation, you have the equation u. So you should begin your tree diagram with the node u. So inside the equation u, you have the variable x, y, and z. So you have three variables, means that you're going to have three branches. So one is n with the x, and then one with y, and then with the z. Okay, let's just look at the equation x. So equation x, you have variable rt, and y you have rt also, z also you have the rt. So it means that all of them have two branches. So you're going to draw the tree diagram like this. Say all of them have two branches. So n with r, another one n with t. So now we're going to write the formula for the del u del r. So the way to write the formula for del u del r, that is very simple and that is very direct, and I'm not going to write all the partial derivative inside this tree diagram. I just need to focus on the r because this example is only asked for del r, so you just have to focus on the branch that ends with the r. So this is the first branch that we have here. So this is actually begin from the node u, and from node u move to x, and x move to r. So from u to x, will give you del u del x, and from x to r will give you del x del r. So along the path, you have these two things. So multiply both of them. So you have del u del x multiplied with del x del r. Okay, plus with another branch. So another branch that ends with the r. So this is another branch ends with the r. So this actually starts from the u, move to the y, and from y move to the r. So from u to y will give you the partial derivative of del u del y, and from y to r will give you del y del r. Okay, so multiply these two. So you will have del u del y multiplied with del y del r. Okay, plus with another branch that ends with the r, that is this one. So this is begin from the node u to z, and from z to r. And since we are moving from u to z, this is give you partial derivative of del u del z, and this is give you del z del r. So multiply both of them. So you will have del u del z multiplied with del z del r. So this is the formula for del u del r. Now we come to the solving part. Okay, so we have known what is our formula of del u del r. The next thing is we need to find the first order of partial derivative. Okay, let's just go with the del u del x first. You can obtain the del u del x from the equation u. So you're going to treat the rest as constant. So you focus on the x. So you differentiate x squared, will give you 2x. Differentiate on x, you have 1. Multiply with constant, you have 3y. So we have 3y here. So this constant is give you 0. So substitute here, so you have 2x plus 3y. So go to the del x del r. So differentiate on the equation x. So del x del r is give you 1. So substitute here, so we have 1 here, plus with del u del y. So the del u del y you can obtain from here. So treat the rest as constant. So x squared is constant. So we have 0. Focus on y. So you differentiate y, you have 1. Multiply with constant 3x, it will give you 3x. And this is constant, is basically give you 0. So substitute here, so you have 3x. Okay, they'll go for the del y del r. So del y del r, okay, can obtain from the equation y. So del y del r is give you 2. So substitute here, so you have 2. And then plus with del u del z. So del u del z you can obtain from here. Treat the rest as constant. So this is constant is 0. This is constant as 0. And focus on the z. So z squared, you differentiate, you have 2z multiplied with 4, so you have 8z. So substitute here, so we have 8z. Okay, then multiply with del z del r. So this is obtained from the equation z. So del z del r is give you 1. So you substitute the 1 here and simplify it. So you have del u del r as 8x plus 3y plus 8z. Usually we will stop at tier 10 for temporary and we look for the further information. But for this question, we do not have the further information. We just have del u del r. But do not stop your answer just in term of the x, y, z. You have to further, okay, this del u del r, okay, you have to substitute your x, y, z with the information that we have here, okay. So just don't stop your answer in this way. Your answer should in terms of r and t. So substitute your x as r plus 3t, substitute your y as 2r minus t, and substitute your z as r plus 2t, and expand them and simplify them. Then you have the answer that is ends with the term of r and t. So your del u del r is 22r plus 37t.